our second carbonyl condensation reaction is the Claisen reaction. Okay. Claisen was a German chemist, so I have to train myself to say it right. It's the Claisen reaction. Similar sort of thing happens where you have two carbonyl compounds reacting with each other. One is an enolate. Okay? One will act as an electrophile. But the difference here is that now we have a leaving group attached to the carbonyl. So because of that, instead of just being stuck at the alkoxide, the O- comes back down and kicks out the leaving group. We end up with beta keto ester, right? So we have the original ester group here of the alpha carbon. The beta carbon is a regenerated carbonyl because we got to kick out that leaving group. So let's take a close look at this mechanism. The base we use, ethoxide, has to be the same as what's attached to the ester that we have. Okay? That's important because if we had used methoxide or hydroxide or something like that, we would have not preserved that same ester group. Okay? We would have mixed it up with the base that we used. We could have had O-methyl or OH or something like that. And it wouldn't do it cleanly. We would have a mixture of products. So to avoid that issue altogether, use the same base as the leaving group of the ester, essentially. Right? So here, ethoxide, in this case, deprotonates the alpha hydrogen of one of the esters. Okay? That alpha enolate will attack the carbonyl of the other ester, kicking it up, making a tetrahedral alkoxide intermediate. And then, because we have the leaving group attached, the O- comes back down, kicks off the leaving group. Okay? So we end up with a beta dicarbonyl. And for these last steps here, let's take a look at the next page here.